Welcome to our introduction on the Pythagorean Theorem. The triangle shown here is a right-angled triangle. The square symbol on the bottom left tells us that that particular angle is 90 degrees. Using a formula called the Pythagorean Theorem, we can calculate the length of any side provided we know the length of the other two sides. For example, we knew that the vertical side on the left was 3 units long and the baseline was 4. We could calculate the unknown side to be 5 using the Pythagorean theorem. It doesn't matter which sides we are given. If we know the lengths of 2 of the sides, we can find the length of the third remaining side. If we were given the sides 3 and 5, we could calculate the baseline to be 4. So, what is this theorem, and why is it given such a funny name? Introducing Pythagoras, a Greek mathematician that was born around 570 BC and best known for creating, or at least proving, our Pythagorean theorem. Before introducing the formula itself, let's consider a few parts of our right-angled triangle. To use the Pythagorean theorem, we must start with a right-angled triangle. That is, one of the angles must be 90 degrees. The hypotenuse will be the longest side and is always directly opposite the 90-degree angle. The hypotenuse side is often given the label C. The other two sides, or legs of the triangle as they're sometimes called, are often given the label A and B. It doesn't matter which of the other two sides we call A or B, it's pretty much interchangeable. Here's the equation for the Pythagorean theorem. But what does it mean, and how do we go about using it? In this example, again, we'll use the letters A, B, and C to label our triangle, remembering that C is usually reserved for the hypotenuse. And also, we'll add some numeric values. A very common right-angled triangle that's often used to introduce the Pythagorean theorem has sides of 3, 4, and 5. So, a triangle with a vertical side of 3 and a base of 4 would have a hypotenuse of 5. This is such a common example that it's often referred to as a 3-4-5 triangle. The Pythagorean theorem tells us that if we take the length of side A squared and add it to the length of side B squared, it will be equal to the length of side C squared. Continuing the evaluation, we see that 9 plus 16 does indeed equal 25. So we can conclude that the Pythagorean theorem is correct. A squared plus B squared equals C squared. When we talk about squaring a number, we're talking about multiplying that number by itself. Have you ever stopped to consider why we call this term squaring to describe this process? We can use tiles to picture an actual square that represents the exponents. Imagine a square that has a length and width of 3 centimeters. When we create a square with dimensions of 3 on each side, we end up with a total of 9 blocks. We are literally squaring 3 to get 9. Now let's apply this idea to the same right-angled triangle from before. Imagine our sides, or legs as they are often referred to, have lengths of 3 and 4. According to the Pythagorean theorem, we should expect our hypotenuse to be 5, because 3 squared plus 4 squared is equal to 5 squared. We'll make our triangle a little bigger so we can clearly count our tiles. Our vertical side of 3, our horizontal base of 4, and a hypotenuse of 5. 3 times 3, 4 times 4, 5 times 5. Let's make our squares from these dimensions. Our vertical side, when squared, contains 9 tiles. Our horizontal base, when squared, contains 16 tiles. And our hypotenuse, when squared, contains 25 tiles. 9 plus 16 equals 25. This illustrates the basis of the Pythagorean theorem. Now let's use this in some examples where we know the lengths of 2 of the sides in order to calculate the length of the third side. We have a triangle here with a vertical side of 3, a horizontal base of 5, and we're being asked what is the length of the hypotenuse. Let's start with our letter labels. We will use C to represent the hypotenuse, in this case the unknown. The vertical side 3 will label A, and the horizontal base 5 we'll call B. So, using our Pythagorean theorem, A squared plus B squared equals C squared. We'll now substitute the values that we know. We know A, we know B, so we'll simply substitute values of 3 and 5 for A and B, and we're still trying to find out what C is. So now we have an equation. 3 squared plus 5 squared equals C squared. We'll simplify that a little bit more, but before we do, we're going to rearrange our equation a little bit. It's usual to place the variable or the unknown that we're trying to find on the left-hand side of the equation and all the numeric values on the right-hand side. So let's just rearrange our equation a bit. We can flip it around so we have C squared equals 3 squared plus 5 squared. Now we can continue evaluating. C squared equals 3 squared plus 5 squared. 3 squared becomes 9, and 5 squared becomes 25. So we can say C squared equals 9 plus 25. C squared equals 34. Now with this equation, we have a value for C squared, but we're looking for the value of C by itself. So if we take the square root of that C squared, it will become C. But what we do on the left-hand side, we have to do on the right-hand side. So the square root of C squared will be equal to the square root of 34. So the square root of C squared is C, and the square root of 34 is 5.83. We now have a value for our hypotenuse. Here's another example. Now this triangle has been rotated around a little bit, but we can still easily find the hypotenuse simply by looking directly across from the right angle. So we look for the right angle, and the side that's directly across from it is the hypotenuse. Let's label that C, and we can choose the letters A and B to represent the other sides. So A squared plus B squared equals C squared is our Pythagorean theorem. Now let's substitute the values that we know. We know the 8 was the hypotenuse, so we'll put that where C was. And we know that 4 represented side A, so that goes on the left-hand side of the equation. Now we're left with B squared. We're still trying to figure out what B is. Now, once again, we're going to rearrange our equation so that our variable remains on the left-hand side and all the numbers are on the right. Let's take that 4 squared on the left-hand side. We'll bring it over to the right where it becomes negative 4 squared. And then we have B squared isolated on the left. So b squared equals 8 squared minus 4 squared. 8 squared is 64, and 4 squared is 16. Adding the number values gives us b squared equals 48. Once again, if we want to know what b is, we have to take the square root of b squared. Therefore, we'll have to take the square root of 48. The square root of b squared is b, and the square root of 48 is 6.93. So now we have a value for our unknown side of b, 6.93. In summary, if you're given a right-angled triangle and the length of any two sides, you can calculate the length of the remaining side. Here's a little fun fact. Pythagoras and his followers believed that beans were sacred and possibly contained human souls. Because of this, members of the Pythagorean school were forbidden to eat beans, and some ancient sources even claim that Pythagoras once refused to cross a bean field while fleeing danger. It's a strange contrast considering that he's now most famous for a clean, logical theorem taught in math class. I hope you found this video helpful, and that you're comfortable now with finding unknown sides using the Pythagorean theorem. And watch out for those bean fields.